Hello and welcome everyone. My name is Peter Robinson and today I am going to talk about Forge scripting. So who am I? I'm Peter, work at Immutable, head of blockchain research. And in my spare time over the last many years have helped drive this meetup. And let's share my screen and share. Okay, so hopefully everyone can see some slides. Can I get a reaction if we've got some slides that people can see? Yep, I've got a thumbs up. All right, brilliant. Okay. Um, so the David Highland-Wood and I, just before we clicked record, were talking about whether this title really captures it and whether it's not really capturing what it's all about. And it is, but it's also probably the big thing is running transactions on Ethereum is really, really hard. And so, deploying contracts and then executing function calls, it's something that, you read about, you learn about, but actually doing is really hard. And so maybe the talk should be executing function calls and deploying contracts made easy, because I think that's really what it's all about. And so I've used Forge script to do this, deploy contracts and execute functions for two quite separate use cases. So one was to deploy contracts individually and then later call a function, or maybe do the two in one go, but have that as a single thing. And then the other usage was that we have had people wanting to do all sorts of performance measurements on the immutable ZK VM. And so I created a script that would deploy all of the interesting contracts, all the main contracts that get used, and then run sample transactions against them. So we had representative behavior of the blockchain. And the idea was that you could deploy all of this on some new blockchain, and then the people could run their performance tests on that new blockchain. So that's my context for what I've used Forge scripting. Um, a lot of this information has come out of the book that the people creating Forge created, and it's a really good bit of information there. So the concept as a top level is that blockchain developers know Solidity. And so, using Forge, you can create tests using Solidity. And you can also write deployment scripts using Solidity using the Forge scripting tool. And so rather than having to use and learn TypeScript or some other language, you can just use Solidity, which I think is a real plus. Foundry's book introduces it as run a smart contract as a script, build transactions that can be sent on-chain. Script can be used to apply state transitions on live contracts or deploy and initialize a complex set of contracts using Solidity. So similar to the usage I've actually done, where you've deployed a single contract or run a single function, or then deployed a complex set of contracts and done stuff. So let's have a look at an example usage. And this is just stealing some of the code that I had. And so you import the Forge script, and then you also import the actual contract that you're going to deploy. And then you can have logging. So, you might have a log file. And so you go VM write file will write to the path you supply whatever string you give it. Another interesting thing is that it's able to read environment variables. So rather than you say hard coding a private key into this script, you can read the environment to load up, say, P key, which could be, say, an environment variable that's got the private key in it. And then you can convert that private key to an address, and you can label that address so that then you could do things just based on the address and the name. And then yeah, you're using console logging, so you know, you can check that the balance is going to have enough balance to actually do and deploy the contract. And then you say, all right, we'll start broadcasting based on this account associated with this private key. And then you deploy a contract, and then you stop broadcast. And then later on, you say, all right, start broadcast again using that private key. So, and then do a function call. And so because you're using start broadcast, stop broadcast, in fact, that VM.stop and VM.start are not really needed. I could have just had one and done both calls. And so what will happen is that when you run that script, you will create two separate transactions that can then be executed against the blockchain, one to deploy the contract and one to do that function call. And so to actually call that code, you use this big long command line. So the dash VVV is the verbosity level. And so the three V's is going to print out the execution traces and for the failing tests. So it's going to give you detailed information about what's going on. But yeah, you can vary that. Chain ID is the chain ID of the chain that you're going to execute on. Priority gas is the EIP 1559 tip. And then you've also got with gas price. So this is either the gas price if you are a pre-EIP 1559 network, or it is the max gas fee that you're prepared to pay. So the tip and the base fee maximum. And then you've got broadcast. So if you don't specify this broadcast parameter, then you'll run your script and you'll just simulate the transactions, but you won't actually run them. So the G parameter, or gas estimate multiplier, what this is about is that when you the simulator simulates the transactions and works out how much gas they're going to use. And so then what you do is you multiply by this gas estimator, and then the code supplies that as part of the transaction. So the total gas to be used, or the gas limit to be used. And so by default, the gas limit is 1.3 times the estimate. So I specified 1.01, and the reason for that was that I had a deterministic execution path, so I was very sure that the amount estimated was going to be the amount used. And as well, with this bit of code, I was specifically trying to actually fill up a 30 million gas block. So I was trying to get, as close as possible to 30 million. And so if I use that 1.3 multiplier, then if the gas estimate was, say, 27 million, or actually probably only about 20 million, say, then multiplying by 1.3 would mean that it would then say the gas limit was 26 million. And so as you get closer to 30 million, it means that you're not going to be able to get to 30 million because, say, if it was 25 million times 1.3, then you're going to be saying that you want to have the gas limit for the transaction to be 32.5 million, which exceeds the block gas limit, so to be rejected. So that's why I used 1.01, but that's a bit of a special case. And so, yeah, you can adjust that multiplier up or down. If you were using code that was very variable in the amount of gas, and you could see that it was estimating one code path, but it was probably going to execute a different code path, then maybe you'd want to increase that multiplier. So then you give it the RPC that you're going to hit. And then finally, you've got the name of the script and the contract name within that file. So that's the thing that you're actually going to run. And so that's great if you don't need to supply parameters, but sometimes you do need to supply parameters. And so, for instance, say you were going to run a script against a deployed contract, then what you need to do is you need to pass in the address of the deployed contract. And what you can do is you can have a function, say run, which takes address as the parameter of where the code was deployed to. And so then you change the actual call to this when you're running the script to specify the signature of the function to be called. And then you finally have the parameters that you want to pass in. And so you can come up with a whole, like array of parameters, and you can have a of any type you like there. So I've shown some of the cheat codes, but there are in fact a whole stack of cheat codes available. And a lot of them just apply to testing, and they don't make sense in the context of scripting. And so one of them is around, so the stuff, I'm just going to go through the stuff that applies to scripting. And so there's broadcast. And so, typically you supply the private key. And so you can either have start broadcast where you can do multiple transactions and you terminate with a stop broadcast, or you can just have VM broadcast and then it'll then use that key or that account for the next transaction. You've got to take your pick. There are some variants on the broadcast function that allows you to specify, either not take a parameter or just take a string. And so what you're doing there is you're associating a private key with an account using the remember key function. You can get Unix time, which can be good to throw into log files. You can pause execution you specify the time in milliseconds. You can also prompt the user, the person running the script, for data. So, for instance, you might decide that you want to have them input the private key. And so, you could have prompt secret uint could be a private key, for instance. I showed that you could do some manipulation with the environment, but you can actually set the environment and you can read the environment in a whole, for a range of different values. And if any of these don't work, I think you'll get a revert. You can also have a default value and only read the environment. And if the environment's not set, then you get a default value. And so that can be useful if you want to be able to override or have a default, but then be able to override the default. There's a whole lot of tools for reading in and parsing JSON and TOML files. So you can just be either looking for a specific key, or you can grab a whole heap of keys. There's a whole lot of manipulation things for wallets. So we've seen address where you convert a private key to an address, but you can also create a wallet, so create a key pair, and then so from nothing, or you can create a wallet, so a public key and an address based on a private key. And you can use a label as well so that you don't have to reference the account by the private key or the account number. There's also make address and key, which again, so make address, I guess, is probably more useful for the testing where you just need an address, but you don't care what the private key is behind it because you're not going to issue any transactions from it. Whereas make key and address gives you the key as well, so you can sign transactions. Another really useful one is derive key. So if you've got, say, a 12 or 24 word mnemonic, you can come up with the actual private key that's associated with it. And so the derive key just assumes that it's the Ethereum Ether type of key that you're after, whereas derive key with the path allows you to pass in the derivation path. I think it's BIP 44 derivation path. And yeah, so that can be quite useful, especially if you're, say, dealing with a key that is, say, from a hardware wallet or something like that, and you're trying to come up with what the key is. You can also parse strings and turn them into bytes and booleans and integers, etc. And you can convert those values to strings as well, which can be useful if you want to then do printing of information. There's a whole heap of methods for reading files and directories and checking if they exist. So there's, lots and lots of tools. And I know that I've gone over things at a lightning pace, but I think this talks more of an awareness that this tool exists. And to really get a good grip on it, you have to use it yourself. So yeah, Forge scripting is a powerful tool. There's lots of complexity though behind it. And I've skipped over a lot of details, but read the actual book. And what I'd say is that if you are looking for a feature but you can't find it, have another look. You might find that it is a feature of the scripting language, and you just haven't come across it yet. An interesting one is actually if you look at that string manipulation I had in my example here, yeah, so I'm using string to hex string, which is something from Open Zeppelin. But as you can see, there's now a toString method. So I'm not sure, maybe that won't give me a hex string, but still it's it shows that you don't necessarily need use Open Zeppelin, and I dare maybe these capabilities came out after the after I grabbed that code. Yeah, so that's about it. Merch store is still open. In 2 weeks' time, it's actually going to be at a 5 p.m. Brisbane, I think, or maybe at 6 p.m. But Stefano is going to do a talk on security vulnerabilities in ZK Snarks. And Raghavendra then is going to do a talk on Supra containers. So some app chains on layer one. So a new concept that they've come up with. And then I'm going to do a talk later on, probably in mid-December. Last talk for the year will be on validity, optimistic, and OPZK roll-up design, and really how to think about it. So I've done a lot of work on that in the past year, and yeah, I think I've got a much better idea of how these things work now, and should be able to give a much better talk. So, and there are some social links. So, are there any questions?
Yeah, I have one, Peter. Um, so I'm with you that not having to switch languages is a reasonable thing to do. But if, Solidity is not my favorite language, and I'm sure that's true for some others. So I wonder if the overall environment is such that you'd really recommend it, or is staying within one language really the only reason to take this approach?
Yeah, I think staying in one language is good, and staying in one tool. The one use case that I can't see a way of doing is say if you want to deploy and you want to deploy using, say, a hardware wallet key, something where you don't have access to the private key, or using a hardware security module, or one of these cloud HSMs or something like that. If you want to use that as the signer, this is not really going to work for you. So that's a use case where I don't think it works. And invariably, then you end up seeing people write it in Python or TypeScript or something like that. Um, yeah, and certainly at Immutable, that's what has been done to, I think we were using a cloud HSM for some things.
Yeah, so that's the negative use case. I'm wondering if there's a positive one. Is there something that you can say about Forge? You just say this is the best way to do it as a
Oh, yeah,
default.
yeah, yeah, yeah. So, on the flip side, I'd say, look, I've used, I've been using JavaScript off and on since it was first created back in the Web 1 era in like circa 1996, 97.
I have too, and yet I feel sorry for you.
Yeah, 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 yeah. And so I've been using JavaScript for a while, and yet sometimes when I look at people hard hat scripts that people have written in TypeScript, I look at it and I go, "What on earth is going on there? I have absolutely no idea." And yet, when I look at Forge scripts, I know exactly what's going on because, I've had to become an absolute guru at Solidity. And so hence, I can understand exactly what's going on. There are, all cards are on, it's open misere, all cards are on the table. And so I think that that's, a good thing. And say using Python as again, it's just another language. And the problem is that, if you're trying to hire people, you say, all right, we want you to be a Golang person for the back end, and you need to know Solidity. Oh, but by the way, you also need to know TypeScript so we can use Hard Hat or this deployment script or whatever. It just adds an extra thing for people to have to know. And I think if you're asking for people to know a bit of Rust, a bit of Golang, and a bit of Solidity, and now you're saying and a bit of Python and a bit of TypeScript. And by the way, we want you to be, like it'd be good if you're a raw grad, so we don't have to pay you too much, or we just need you to know these five languages. And it'd be good if you had 6 years experience with Ethereum too.
Right,
Yeah, good thing you started when you were in primary school. Um,
right. Before Bitcoin came out, right?
yeah, 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 yeah. So I do that I think is why it's probably a good move to try and just reduce the amount of things that people need to know and also keep up with, because that's another thing that I find with our TypeScript test system is that they'll rely on some tool, and then that some library will get updated, and then you think, oh shit, do we need to upgrade all of this? And whereas Foundry, I mean, it's there. Another downside though of Foundry is I don't think they're up to 1.0 yet. Though they've been going on for a long time, you're invariably just getting the latest nightly build, and every now and again they break something. Not often, but sometimes they do, and that is a bit strange. It'd be good if they could just say, "Look, we're good enough. Here, we're going to do a hard solid stop, and this is, like 0.9, and you can do the nightly build, or you can use 0.9 or something. That'd be something that I think would be nice. But no, well,
Yeah, makes sense. Thanks.
yeah. Are there any other questions? All right,
Are
I've got a
are
question.
you aware of any Foundry-like libraries that would allow you to utilize other languages besides Solidity? I know, for example, Arbitrum has they recently released Stylus, which compiles down to their multi-VM and allows you to basically write Solidity bytecode. I'm curious if you're familiar with any Rust-based scripting for that is quite similar to the Foundry workflow.
Yeah, I don't know of any. Yeah, I don't know of any, but yeah, the and it, yeah, not to say, I mean, the thing is, the thing with tooling is that there is always a new tool chain coming out. And so though Foundry are, I think are a good leader at the moment, yeah, something new might come out. But yeah, I'm not aware of any other tool chain that's like Foundry, say, with Rust.
Okay. I have another question.
Sure.
So I know research teams, for example, like Flashbots, when it comes to MEV, they use either I don't know if it's Foundry or if they use something else, but they do something quite similar where, for example, they'll analyze the blockchain and then they're able to execute certain transactions based on inputs and that kind of thing. Um, are there have how do you track performance in terms of response times between receiving information from the blockchain and then sending out requests as quickly as possible for in order to orchestrate transactions, for example, flash loans that need to happen in the same block that you're executing and things like that. Does Foundry fit well within that use case? And are there other considerations or other ways to measure performance or optimize within the tool itself?
Yeah, so you're essentially saying running some sort of bigger script, say that reads the reads the blockchain and says, "Hey, there's an opportunity here," and then in the next transact, then goes through and does some flash learn and does something based on it. Yeah, I have not tried found the Forge scripting in that use case. I'm trying to think whether it because I know at the moment it likes to um, estimate, estimate all of the transactions. But if you're going to be, say, in an infinite loop, because you're just going to loop around forever, get value. If the returned information isn't right, then sleep for say 1 second and then try again and do another read. Yeah, I'm not sure how it would run and how whether you can turn off the capability for it to estimate gas. So I think there are ways around doing that. So maybe that'd be what you'd need to do.
Ah, okay. Okay.
Hmm. Yeah, but it's an interesting one though. It's the thing is though, you're mentioning that you wanted to have a high performance server that wasn't going to fail. Then you could imagine that would, yeah, you'd probably want something a bit more bulletproof. So I don't think Forge scripting is designed for that sort of use case. Um, but it'd be interesting to see how it'd go if you tried.
Yeah, yeah, I think I'll go through the book and experiment a little bit more with it and see if, on the test net we can see what kind of issues I run into on that.
Yeah, yeah, it sounds like an interesting use case. Yeah. Are there any other questions?
Thanks,
I
Peter.
have
Great talk.
I have one
Oh,
more
yeah, yeah, yeah.
question.
Yeah, sure.
I
Go
did
ahead.
Yeah, I did notice that StarkNet has also has a Foundry library. Are there do you know of the differences between that and how they relate to each other, or if they are because I know StarkNet is using well, they're using Stark's and Cairo as a programming language. Is it essentially the same concept but built within the Cairo language?
Yeah. StarkNet Foundry. There you go. I have not even seen that, so I've just done a web search right now. And interestingly, all right, so there is a StarkNet Foundry book even. I mean, I guess what the acid test will be is how similar it is. Yeah, it does seem to need a whole lot of annotations. Just looking at the book, it needs annotations and stuff, and the actual code itself looks quite different. So
Hmm.
I dare say that that might mean that though it's based on the same tool chain, the actual result is a little bit different.
All right, cool.
Yeah. All right. Thank you everyone for coming along today. Hope you've learned some things and have a great rest of your day. Bye-bye.
Thanks,
Thanks,
Peter.
Peter. Take care.